Morning, everyone. Just want to introduce myself before we start. My name is Dr. Akshay Vij. I'm a faculty member here at Missouri School of Dentistry and Oral Health, MOSDO, at ATSU. I primarily work at the St. Louis Dental Center, where our third and fourth year dental students, treat patients, and we have our clinic over there. So they spend their first 2 years here, and then they move to St. Louis, where they treat patients. I'm the director for aesthetic and digital dentistry there. So today, what I thought was, when Aaron asked me to speak, I thought what I could talk about is how 3D printing, actually both 3D printing and milling, which is additive and subtractive manufacturing, is revolutionizing dentistry. Also, to give you perspective, I also put in some videos of how it used to be done, and it's still done in many places for like the last 100 years, and then how 3D printing or milling is really changing the way we are doing things in dentistry. I also threw in some patient cases so that you can actually see what the end result looks like in someone's mouth and how it makes our life easier. So how many of us have had an experience like this at a dentist office? So, I get why people don't like dentists, this is how we've been impressioning teeth or a patient's jaw for, 50 plus years at least. Materials have advanced a little bit, but not that much. The concept still has been the same. You take some material, you make a mold of someone's, jaw. It's come from other industries. That's been done so many times. Materials have become better, more comfortable. Doesn't taste as bad, sets quicker. All of those things. But the concept has still remained the same. So what happens next after you make that mold? Right? So you made that mold, now you need to bring it into the real world. So we actually use some stone. This is type 4 dental stone, similar to dental or plaster. Same concept. We pour it in, let it set. It's a mess, and then we create a base to make it stronger. So that's the patient's teeth. We trim it, clean it up. And this is sped up, so it's quite a long process. It takes maybe 20, 30 minutes to set. You need special equipment. You need you or your assistant to do this, and that's the end result. So we can actually study the patient's mouth. Now, there's a lot of problems with this. It is accurate if it's done correctly, but if it's done incorrectly, there's a lot of voids and bubbles and things break. And remember, if you want more copies of the same, you have to physically pour more copies, more mold, right? It's not like you can make one impression and make 50 molds out of that, or casts out of that. Now, how many of us would prefer an experience like this? Oops, sorry, skipped over that. Right? So this is an intraoral scanner. So, digital dentistry begins with acquiring data. So in the analog world, we acquire data with taking an impression. Here, we're actually sequentially scanning the patient's mouth. You can see how much more comfortable the patient is, the dentist is, how much quicker this is. It's super accurate. So, who wouldn't want an experience like this? You can imagine, especially with, patients that have a gag reflex. As we saw in the video, this is a lot better. Kids who don't like impression materials in their mouth, it's a much more comfortable experience. And at the end of it, we have a 3D model that we can actually, toggle around, rotate, look at it in different directions. We can print out copies of it. And I'm going to show you that in a little bit. And this is what the end result looks like. We have digital models that can then be emailed or sent anywhere across the world. You can use this to, consult with other specialists, give it to the patient. I've even had, I usually do this at the end of my treatment as well, not just at the beginning. And I give it to the patient. And I'm like, if you ever break a tooth, now you have a mold of your mouth that's perfect. So 5 years from now, you break a tooth or something like that happens, you now have the blueprints to your mouth, right? And as we know, storing digital files is a lot easier than storing, physical casts. I think state laws say you got to hold it for 7 years. Most dental offices will keep physical casts for 7 years. because we have to, but you can imagine with thousands of patients in a practice, you would have to almost rent out an office just to store models, right? Whereas this can just be stored on a server. You can also manipulate these files digitally. So let's talk about how we would bring this into the real world. Let's say you did want a physical model. For some reason, you needed to work with it, you wanted to show it to the patient, whatever the reason is. So today I'm going to talk about both additive and subtractive manufacturing. So in some cases, based on the material, additive manufacturing or 3D printing is more appropriate, easier, cheaper, faster. And in some cases, subtractive manufacturing, which is milling, where you take a large chunk of material and then you carve out what you need, that's more appropriate, right? So I'm going to show you examples, and we use both in dentistry, extensively wherever it's appropriate. So when we want to bring that patient's model into the real world, we happen to have a SLA printer, it's Formlabs, and it prints it layer by layer. There's a laser that cures the resin. Most printers work that way. That cures the resin, and depending on the print speed, maybe in 30 minutes, maybe in 2 hours, you can even set the accuracy of the printer. You want 25 microns accuracy versus 100 micron accuracy. 100 microns would be faster, but it's less accurate, right? So depending on what you're planning to do with this, you set your time and your accuracy. So this is what a 3D printed model looks like at the end, right? So a lot easier going from that scan to a model than what we saw earlier. And another advantage of this is you can print at scale. So I could print 16 models out at the same time, right? It's the same file, copy pasted 16 times, and print it. You're basically just limited by the size of your working area or the printer bed, right? So you have printers that can do a lot more than this, or you can have printers that can do a lot less than this. So and the cost of the printer changes. So you can see we've laid out on how many of these? These are 16 models of the same patient, and we printed it out. You can think, you can imagine the time saving that happens, and not just casts. And I'm going to go over different applications in dentistry, but this happens to be dental models. These are dentures. These are wax castings. These are surgical guides. So you can print a whole lot of different things because they're all made of resin, right? So this happens to be a dental model resin. Now, let's talk about how we use this. Why is this useful? One aspect that Brian went in much more detail about how it's awesome to simulate the surgery before you go in there. Whether you're a student or you're an experienced practitioner or a surgeon, you want to try and study that case before you go in there. It's a lot faster, a lot more efficient, a lot safer, a lot more predictable when you can do that. So in this case, we printed out the patient's mandible and we simulated placing dental implants. So this could be how we train students. It could be how a surgeon learns to appreciate the anatomy before going into the surgery. And then you can actually place the implants in there and then replicate that same surgery in the mouth, right? So I'm going to talk about this more in detail. Another example, this is actually a dental student. She was missing her 2 teeth congenitally, so since birth, and finally she's old enough to get implants, but she's missing a lot of bone because when you don't have teeth, you don't have the bone for implants. So what we knew is we're going to open this up and have a titanium mesh and build that bone back. Now, when you make a titanium mesh, it's a big mesh, and then you got to cut it out. And if you're doing all this while the patient's in the chair, the patient's sedated, anesthesia is going on longer, it's a lot messier. You're going to have to work in a different operatory. So what we decided to do was we actually printed the patient's jaw out, and we cut the mesh beforehand, shaped it, made the holes, made it exactly as we needed, in the comfort of our office. And then this is the surgery. It went right into place, almost instantaneously. So you can imagine how much more comfortable for the patient this is, not having to cut a piece of metal around them. How much more sterile the environment is because I'm not having to leave, do this, come back into the operating room. How much faster, more efficient this is. How many more surgeries I could do in a day if I didn't have to do this. I did do this next to the patient. So, this is just an example of how printing these models can really help us simulate patients, simulate the case. Another example, this patient came to us, he's missing his lower left, all his teeth here. Several years ago, he had some radiation. His teeth had to be taken out before that. So he's missing these. Now he's finally ready, both financially and mentally, to get himself rehabilitated. This is actually quite a complex case because he's missing quite a few teeth. We know we want to put some implants and we want to give him something fixed and something that can replicate the teeth that he lost. But the surgery is quite complicated because if the implants don't go exactly where we need it, the prosthesis or the teeth on top of it won't fit, or it'll complicate that a lot more. So what we wanted to do, what we did is for every implant surgery, we take a CT scan, and then we have a planning software where we can actually virtually place implants, and it lets us, appreciate any nerves, any blood vessels, so we can simulate the surgery without knowing what challenges there are in this case. Do I have enough bone? Do I not have enough bone? Is the bone where I need it to be? Am I going to hit any nerves or any blood vessels? So I can simulate and I can place these virtual implants in there. And I'll talk about this in the next slide. And it also gives us a chance. So here it's me and Dr. Crane. So at Moscow, we have an implantologist who actually places the implant, and I and Dr. Kruger actually help with the prosthesis on top. This gives us a chance to actually discuss beforehand. Remember, no surgeries happened yet. We're simulating the whole surgery beforehand. We're trying to anticipate any complications and any of that beforehand. So having this 3D reconstruction through this software actually lets us simulate the surgery. So what do we do next? So we actually put in these fake teeth in the software, and then we place the implants right below those fake teeth because that's where we need it, so it can support the crowns eventually. And then we design a surgical guide. Because now the challenge is, yes, we've placed these implants virtually and they're exactly where we need it, but how do we now physically make sure those implants end up going where we need them to go, where we plan to go, right? So we make a surgical guide. Here. And this guide is pretty accurate, actually. It's our SLA printer can print up to 20 to 25 microns, which is 0.035 millimeters, which is pretty good. So this is a guide that we designed, and what a guide basically is, all your drills, anything that you drill goes through that guide, and it kind of forces you to be in place. It doesn't let you veer off in different directions while you're doing surgery. So what we then did is we printed the patient's jaw out, and we actually did a mock surgery. So we simulated the whole surgery, and we actually placed those implants just to make sure what we saw on the screen is what we'll actually get of the model. And then this is the actual surgery in the mouth. So they're exactly where they need to be. And then this is where the patient ends up, right? So the surgery itself was fast. I think the surgery itself didn't take more than 45 minutes. Of course, we spent 2 hours planning it, but that's planning it, and the patient's not in the chair. It's a lot less stressful. The patient's not numb. They're not under anesthesia. You're walking through every scenario. You have a team of experts sitting there and talking through every complication. You're doing all of this without the patient being there, without the clock running, without the patient bleeding, right? So you can do all that, and in the surgery itself, and once all of you agree on a plan, you go ahead and execute it, and then it's not that hard, right? So we placed those implants. We waited about 6 months to heal, and then we went ahead and put the prosthesis on top, and this is how the patient left. But this became a lot less complicated, a lot more predictable. Because if there were problems and if we needed some additional surgery, all of this we could explain to the patient beforehand, right? It's a very uncomfortable uncomfortable situation where patients numb, reflected their gums, and now we realize actually we don't have enough bone. We're going to have to do another surgery, right? At that time, the patient is not able to actually understand what you're saying. This is not what they signed up for. The cost has increased dramatically. They could have gone for a different option, right? So that planning actually gives us the opportunity to go through every scenario, show it to the patient. Is this what you want? And this is what we can execute, and this is what we can't execute. And so in this case, we were able to help him, and this is how he left. So let's talk about. So we spoke about 3D printing. So I showed you those dental models, the surgical guide. They're all made of resin, and resin is very conducive to 3D printing or additive manufacturing because you can cure it. Your laser can cure it, and you can build it layer by layer. But sometimes some materials are more conducive to milling or subtractive manufacturing, where you should take a chunk of material and then you carve out what you need, right? So let's again, I want to show this video to show you how things were done for, actually the casting itself is what, a few hundred years. I mean, blacksmiths did it in medieval times as well. But it's the same concept, right? You make something, you make a mold of it, you pour molten metal in it. People have done it for jewelry, for swords, for weapons, for dental crowns, right? So this is how a dental crown, a metal dental crown would be made conventionally. So again, it's an age-old concept. It's nothing new. So let's say we had a patient where they needed a crown in their front tooth, made an impression, and then we have a dental cast. And what we then do is we create a wax pattern, or we create the crown that we want to create for him in wax, and then we're going to invest it. Let's go to the next one. Now the question is, how do we go from that wax to that final crown? So these are the steps. You invest it, you put it in some special stone that can resist heat. You screw it, you make an attachment to that wax. You put it in this special ring called an investment ring, or it's almost like a crucible. And then you pour into this ring some investment stone, which is actually like plaster. It's got the properties to resist that high temperature. So we're going to mix some stone. So it's going to pour around it. It's going to take it's essentially creating a mold of that wax. We let it set, let it harden up. And then we burn out that wax in a high temperature oven, because the wax melts before the stone, and that leaves this empty shape into which we're going to pour some molten metal. So we put the metal in there, and under high temperature, we push in some molten metal. We cool it down, break this ring, and that's our crown. And now we're going to actually finish it, polish it to actually make it, go and make it go into the mouth. So this is how it came out. We're going to shape it a little bit. We're going to polish it, and this is what we end up with, right? But you saw how many steps it took, how many potential chances for error at every step, what kind of machinery you needed to do this. So these are big industrial furnaces that do this. It will be hard to do this at scale because you almost have to do each one by hand. Again, this concept of casting has been around for hundreds of years. So we actually do this really well because we know the materials. We experimented for hundreds of years. And we know what the temperatures are and how molten it needs to be and what are the errors, and we know how to compensate for those errors. There's shrinkage of the metal and expansion of the metal, all of those things. But let's look at another way of doing this. So instead of so you guys saw in the first slide an intraoral impression, and imagine I import that impression into this design software. So we skipped all those steps. We skipped the impression, the physical impression. We skipped the pouring of the actual cast. We skipped the making of the wax pattern, and we're going to do it all digital. So we went right from the mouth into this software. Right, this is a tooth ready for a crown. We draw the margins. We design a crown virtually, so no wax needed. And because we can zoom in and we can really be accurate with our design down to microns, which it's hard to do by hand. And then in a big chunk of zirconia, we had 8 crowns because there were 10 crowns for the patient. We had 10 patients, and we could do this, mill it out all at scale. So you'll see this is a puck of zirconia, which is a type of ceramic, and we have a machine that actually mills out all these crowns. So we did how many of those? I don't know, maybe 10, 12, 15 at a time, right? So you can imagine how much more efficient this process is. We finish it, polish it. It's not still at full strength, so we're going to put it in a high temperature oven called sintering, where it changes the properties of the zirconia to make it, give it its final hardness. Take it out. Again, we finish it, polish it. We characterize it to customize it to the patient's own, to their color of to match the rest of the teeth. We bake it. We glaze it, which gives it a nice shine. So it's smooth to touch with your tongue, and it's kind to the opposing tooth. And this is the end result, right? So you could see the difference in the manufacturing method. It can really open up more with, it definitely makes it more efficient, more cost efficient, time efficient. You can have a lot more control on a digital design software versus hand, right? So it really is revolutionizing what we do in dentistry here. I think at this point I would be hard pressed to find a lab that is still making their crowns, casting. Most have moved to something like milling like this. So this happened to be zirconia, the tooth-colored ceramic. But the previous example that I showed you for casting was metal. What if you wanted to do this with metal? So you can even mill metal, right? So this is a puck of metal, and you're actually, cutting out a crown out of it. The advantage of milling is because it's not the puck of metal is super dense and it's at final strength, and you cut out this crown. It's actually the crown is a lot more stronger, right? But you can appreciate how much material you're still wasting, right? We took this huge chunk of metal, which is expensive, and then we cut out what we need, and it's got these attachments which you have to discard, and the only usable part is in here, right? And everything else gets wasted, right? That's why 3D printing is more efficient, because you use only material that you need, right? And everything else can be reused. So this same metal crown, let's see if we can 3D print it. So this is an SLS or SLM printer, selective laser melting or selective laser sintering, where we can now 3D print the metal itself. So again, we're designing the supports. This is simulating what we're planning to do. This is actually a simulation of the 3D print layer by layer. And then in an SLS printer, you can see a laser is selectively melting. This is powdered metal, where it's melting the metal and it's building only what you need. Right? So this is how the structure comes out of that powder bed, and you just brush away what you need, what you don't need, and you have that emerges out of it, right? So you can imagine how much that material that you brushed away, that still gets reused the next time. So you've not wasted any material, right? So you can see how much more efficient this is even compared to mill, right? So in some cases we 3D print metal. There are problems sometimes with porosities. It's not as this 3D printed metal is not as dense as that mill, but those problems are being worked out. So in some situations where it's not a stress-bearing area, we would like to 3D print it. But if it's a stress-bearing area, we would like to mill it because we want it dense and strong. So depending on what type of application it is, we can choose either manufacturing method. So coming to near the end of my presentation, this is something we do at Mosdo at St. Louis Dental Center every day. Patient comes in, needs a crown. We do it in the mouth, and then we design it right there in our clinic. You can see the amount of control we have because it's on our computer screen. We're going to mill it out of a chunk of ceramic, and this is what it looks like. So this is it's still better to mill it because it's denser and it's a stronger, when the patient bites on, we don't want that crown to break. But there are now advances happening where ceramic will be eventually 3D printed. In fact, there are already prototype materials that are not yet FDA approved But currently, this is the easiest, fastest way. So again, this whole process, although this video is sped up, this whole process from that design to the mill took about 15 minutes. In a conventional workflow, where prep the patient's mouth, take an impression, put them in a temporary, they go home. 2 weeks later, they come back, and I cement that crown. Right here, I'm cementing the crown about 20 minutes later. Right. So, sometimes patient, you can imagine how much more convenient that treatment is, right? If you're busy, you hire a babysitter, you come to a clinic, you don't have to do this twice. You can walk out with your tooth the same way. In some situations where it still needs to go to the lab and that happens, but most commonly a patient comes in with broken a tooth, they can actually walk out with a new tooth that same day, right? A new permanent tooth that same day. The number of things you're avoiding, we spoke about how comfortable that process is, instead of me taking an impression of their mouth, or scanning their mouth, and while they're waiting in a chair or they're in the waiting area or they gone to get some coffee, I'm going to make that crown and they come back and I cement that crown. So, it really opens up so many options for us and it makes it so much more convenient for our patients. Whether you're busy executive who can't come twice, can't take 2 half days off work, I can imagine that, or someone who's hired a babysitter and come from 2 hours away, doesn't want to come for 2 appointments, and I get that. So this really gives us a chance to help those patients out who otherwise would not have gotten that treatment just through sheer lack of time. I'm going to give you another example. So we make, patients who are missing quite a few teeth, we make something called partial dentures, where we replace the teeth that are missing. It's a prosthesis that comes in and out. This is actually a good case because it's a combination of 3D printing and milling at the same time. So in this example, we're actually virtually designing our partial denture. This base, which is going to look like gums, is actually 3D printed. So we're actually printing. It doesn't have the teeth on them yet. It just has the gums here. We're going to polish it, take out any excesses, polish it, make it shiny. And then those teeth were actually milled. And then we're going to glue in the teeth. And this is the end result. So this is actually a combination of 3D printing and milling, and it gives you a prosthesis. So again, we're kind of spoiled with all these manufacturing processes. We use what's appropriate for that scenario. We're not married to a 3D printing or a direct 3D printer or milling. Whatever's appropriate for that case, we can use the appropriate manufacturing method. Another example I'm going to give you is denture. So, patient loses all their teeth, and we're going to make a denture for them, replace all their teeth. Earlier, again, for over 50 years, the way this denture was made was it was made in racks, and then we do a version of casting, which we say processing, and we actually put in acrylic. Instead, we could 3D print the denture. So we designed the teeth, and we have a 3D printer that has a denture resin. So the patient's gums are going to print out of a pink resin, and the teeth are some white resin. We're going to glue it together. We're going to cure it. We're going to wash off any excess resin with alcohol, polish it, and then we're going to customize this to the patient's needs to, so that it looks like their own teeth. And this is the end result, right? So something that would take maybe a few days is now being done in a few hours, right? I think that's all. So this is our CAD cam room at the St. Louis Dental Center. We have milling machines. So the video that you saw of us milling a crown, that's on milling machines like this. This is our 3D printer. This is our intraoral scanner, oven to bake stuff. So this is, our students and our faculty get a chance to do all of this. Our patients, so we, if patients want it the same day, we have the ability to do that. We've had a lot of patients who just, have had traumatic experiences with dentists before. Not because there was anything traumatic about it, but because just the process of going through that impression, and they remember gagging, and they remember it as a child, and they can't get themselves back to do that. We have a pediatric department, so a 7-year-old boy is not going to sit through an impression for 2 minutes. It's just not going to happen. So often we have to defer treatment because we can't have a patient that's cooperative. But when I did this, when I scanned this patient's, this boy's arch, he thought it was a video game, so he loved it, right? So, great. Yeah, any questions?
How, yeah, I guess the students that are rolling through these days, how have they changed? You mentioned kind of the whole video game idea.
Right.
Are you seeing students adapt that way?
Yeah. I mean, when I went through it, I kind of had both ways of doing it, and I remember as a student when I had to do the tasking myself and learn how to do it, it was traumatic for me. Let's say that. And now, because the current generation of students are so comfortable with technology anyway, they're whether it's their smartphone, they're using 3D software anyway, and this almost enhances their learning because now they want to do it. And now it's almost you can't keep them away from it. So once you teach them this, they want to do every case like this because they have their ultimate control. They're not sending it off to a lab where they can't see what's happening. Here they can play around with it on the computer. They get immediate feedback. That's huge. So if you did something wrong and it's not working out, you still have the patient there, and you know that in a matter of minutes versus you having done this, sending it to the lab calling you the next day, actually you didn't do this right. We need to bring the patient back in, right? And how much more frustrating that is for the student, for the dentist, for the patient. So the students themselves, they're embracing this, in a big way. That's how I embraced it, and it was exciting. It was the first time I could, wrap my head around it, and even the control as dentists, we're almost, we're type A personality. We like control over every step to make sure that the end result is good, and this gives you ultimate control over it because you have design softwares. You can measure things in microns. You're not estimating things. Yeah, so it's helped us in education. It's helped our patients, of course, but it's helped us educate our students.
All right, questions?
Thank you.
Thank you.